with the solution to question 13b, part B, it's a great question. The solution has in it some techniques, and I guess the number one thing is you would find it difficult to get started with this solution without spending some time looking at what the question is asking you to do. So don't rush any of this. So the question now has an integral sign in it. And I guess what we would be doing, because B followed on from A, we would be trying to tie our answer from A somehow into B. There is no integral here in our solution to A. I guess we do know that if you're asked to differentiate, then the integral is the integral of this answer takes me back to the original expression. But at the moment, that integral sign is not helping. This x cubed e to the minus x squared does actually appear here, x cubed e to the minus x squared. But that's about it. This is nowhere. This is not helping at all. You know, honestly, what is that about? And it'll be quite a while before we actually even see that in our solution. Most questions, however, that say hence show mean we take what we found in the previous part. The only difference being here is instead of me writing y dash equals minus 2x cubed blah, I'm going to write it as d dx of x squared e to the minus x squared is equal to minus 2x cubed e to the minus x squared plus 2x e to the minus x squared. The reason I'm writing this will become obvious in a moment. So I guess that's technique 1. If you're keeping count and you're wanting to make notes, it's technique 1. There is another way to write y dash equals a solution, and that is by starting with the basics. When we differentiate with respect to x, this function, then this is what we got. Like I said at the beginning, I really like this question because there's so many little things in it that are just general problem-solving techniques. So anything, obviously this will only apply in a calculus-style question, differentiating, integrating. Okay, so remember that when we looked in detail at the actual question, we observed the integral sign? This statement has no integral sign in it. However, just like this is an equation, and just like I might take the square root of both sides of an equation, or square both sides, or add 10 to both sides, I can treat this equation in the same way. However, what is it that I want to introduce? What I want to introduce is an integral sign. So I'm going to say the integral of this would be equal to the integral of that plus the integral of that. What am I doing in effect? I'm taking the integral of both sides of an equation, which means I'm taking the integral of every term. What have we seen here? maybe technique 2. Okay, I quite like that I've got this x cubed e to the minus x squared, because apart from that minus 2, it's very much what I'm trying to show. It's almost what I'm trying to show, that the integral of just x cubed e to the minus x squared is this. I still can't see where that's coming from. No idea. No idea yet. Having realised that this term here is what I would actually like to have the integral of, let's do a little bit of work on that. So what I'm going to do is say, well, the next line could be the integral of d dx of x squared e to the minus x squared. And by the way, I should have been writing the integral with respect to x, the integral with respect to x, the integral with respect to x. And we'll come back and interpret this in a moment. We know that if we've got a constant inside an integral sign, we can take it out. Now, what's the advantage of taking it out? It creates for me exactly what the question has asked me to show. So I know that we've got a lot of other things. We've got this term here, we've got this term here that looked nothing like the pink bubble up here. But all I have achieved is at least I've got the beginning of the show. Now, I would like it by itself on the left-hand side, which would be very easy to create by simply bringing it over here. So next line, and that produces, the minus 2 becomes a plus 2, the integral is equal to, now the way I've set this up is because this was positive, I put it at the front, and when I bring this one over, obviously it becomes a minus. So I'm treating these terms just like terms in an equation. It comes over and becomes a minus. I'm not going to do anything with this. I'm really happy with that at this stage. I'll deal with the 2 a little bit later. So I'm going to leave that as x cubed e to the minus x squared dx. It's exactly what we wanted in the show. Let's have a think about this. The integral of 2x e to the minus x squared. Normally we would look at that and go, what's going on? What is going on? You're asking me to find the integral of a product of x terms. Here's one term in x called 2x, and here's another term in x, e to the minus x squared. You're asking me to differentiate a product. Can't do. Unless, can I simplify it? No. The other situation is, have they given me the derivative of the exponential aspect of x? And you can see they have, all except the negative. All except the negative. If that had had a negative 2 in front of it, then I could see that what was differentiated to give me this expression here was e to the minus x squared. But remember, because differentiate that, you get e to the minus x squared times negative 2x. There was no negative, so I have to put a negative in. So now I've been able to take this and totally transform it into minus e to the minus x squared. Okay, let me try and get an understanding of what's going on here. Well, this is actually the easy one. if you take the integral of the derivative, then you're undoing it all. The integral of the derivative gets me back to that. So it's back to, I can simply cancel out integral and derivative and say I've simply got of x squared e to the minus x squared. This is looking much, much nicer. We're getting very close to this sort of thing. And that's just reminded me that when we take the integral of these things, excuse me, we would have a constant. We might have a constant there and a constant there, but we group it all together and say we've got a constant. Now, at this point here, recognizing that we've got the function in the derivative of the function in x, so we might have recalled not so much a technique, but a rule that if we've got the integral of f dash x of e to some function in x, then that is equal to e to that function in x. What must be appearing? The actual derivative of the function must be appearing at the front. Okay, we are now at the stage where we can deal with the 2. So what I've done is divide everything in the equation by 2. So, and we do that to equations. We've been doing that for a long time. So this term divided by 2, this term divided by 2, and that constant divided by 2 just becomes another constant, just giving it another name. Now, I'm going to take out a common factor. And the reason I know to take out a common factor is very much driven by what the question is asking me to show. I'm thinking, I've got these e to the minus x squareds and I've got a half. Where does the x squared plus 1 come from? And I've got a constant. Well, let's do that. So I'm being driven at this stage, my next step, I'm being driven by what the show question actually looks like. Since it's my guide to where I'm heading, it's only natural that I would use it to guide me. And then you can see when I've taken it out, the minus e to the minus x squared on 2. Why do I take that out? Mostly because of what's written here, minus e to the minus x squared on 2. So that was my reason for taking that out. I get, if I take out a minus, then that's a plus. That's just 1. If I take out a minus, this must be a plus. They didn't actually write it as 1 plus x squared, so I had to turn it around. 1 plus x squared is x squared plus 1. So, like I've been saying, really nice questions, lots of techniques, rules, being guided by the show, the content of the actual question, being really guided by that. All of those things you will use throughout your maths. So, yep, great question.